I'm working on the harmonic motion lab, lab 19A, which I typically call the Pendulum Lab, and I'm addressing part 6 here, which says sketch a graph of the motion using amplitude and period. So this is a simple harmonic motion graph. We have experienced graphing stuff, but not simple harmonic motion, so here's your first taste. You're going to get another taste of this stuff in the upcoming days. And this is a good review for our final test that will have graphing on it. So it says that we need to put time in seconds on the horizontal axis, and then this isn't labeled very well because it tells you the unit degrees, but we're talking amplitude here. So this axis is going to be amplitude, and then it's going to be units of degrees, and I'll show that on the main graph soon. So if you're paying attention during class, I suggested you use this chunk of data, the middle data table on that supplemental sheet that I gave you, and 30 degrees, sorry about the herky-jerkiness here. I do this on my computer, but it doesn't show up graphing very well, so sorry about that. So I said 30 degrees and figure out the period. Remember, the period is twice the number that shows up on the CPO timer. So this is an average of all the data in one of my classes. I put them all together. I came up with a period, the time it takes to go from one side over to the other and then completely back to the other side. That's 1.6948 seconds. So I'm going to cheat because we don't need to be that precise. I'm just going to call that 1.7 seconds. So now we got to graph that information. And this piece here says you got to show several seconds. So I'm going to get at least 5 seconds on this x-axis. But I'm going to save that for last because that's the harder of the two. So this point over here, this 0, that's where the pendulum will hang at its lowest energy state. That's the equilibrium state. So I got to draw a line in the center of my graph and call that 0. Now the problem is this guy is 19 lines, so it's not going to be perfectly in the middle. But if I start right about there and draw a line across, I'm going to be okay. Oof. I said my computer does a bad job. Doing this with my phone in my hand and one-handed, not a great line, but we'll live with it. So that's 0. And remember, this is amplitude, and it's measured in degrees. So reviewing our rules for graphing any axis, first thing we're going to do is figure out the range. The range is your highest number minus your lowest number. So our highest number is 30 degrees, and we got to get back to 0. So that's equal to 30 minus 0. Oof, me without a calculator. That's 30. Okay, that's the spread of the numbers we need. Then we take that number and do what's something called the calculated value. So the calculated value is the number that we would make, the exact number that would make this graph as large as possible in either direction. So that is the range divided by the spaces. And so that's 30 divided by, let's see here, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh boy, me without a calculator again. 30 divided by 9, that's 3 with 3 left over, so that's 3 1/3, so that's 3.33. I don't love by counting by 3.33. So what I do is I do an adjusted value. Sorry about the view. And to get that, I double that previous number, the calculated value, so that's 6.66. And so now I can find a number in that range that's easy to count by. I'm going to choose 5. Okay? So we go over here. I don't like writing down every single number because I'm kind of sloppy, so I'm going to go the first line 5. Next line 10, 15, 20, 25, 30, and I could go 40, but I don't need to because my biggest piece of data is 30. So that's one side of the swing. Now we got to go to the other side, so you just repeat that pattern, 10, 20, 30. Okay, so that wasn't too bad. Now here, we've got to get our numbers for time here, and we want to get at least 5 seconds. So I'm going to say, okay, the range is equal to our biggest number 5 minus our smallest number 0. That equals 5. Then I'm going to divide that by the spaces, and I already counted these bad boys. That's 35. So 5 divided by 35, that's 0.1429. Oof, that's an ugly number to count by. So I double that. That's 0.2858. And I choose a number in between those. I'm going to go 0.25 because I can count by that pretty easily. So here, I start at 0. That's 0.25, 0.5, 0.75. That's 1 second. And so 1, 2, 3, 4 lines, I go up a whole number. So 1, 2, 3, 4 lines, that's 2. 1, 2, 3, 4, that's 3. I'll count to myself now. So I got to 5, but pretend I forgot that. I'm going to go to 6. There's 7. There's 8. So I got to 5. That's more than half of my graph, so I'm feeling good. Let's label this time in seconds. Okay. If you thought that was tricky, here we go. So now, when you plotted your points, and I'm using 30 instead of 20 here, you started out at one extreme of that pendulum swing. So at a time of 0, I'm starting out at 30. So here we're at a time of 0. I'm going to put my first point right there. Then the pendulum's going to swing to the other side, hit 30, and then come on back. How long does that take to complete that full cycle? 1.7 seconds. Okay, yours is going to be a little different. So I'm going to go down here. Here's 1.25, 0.50, 0.75. 1.7 is right about there. So I'm going to put my dot at that point there. Okay, so now, how long does it take to complete a second cycle? 1.7 seconds more. So that'd be 3.4 seconds. So here's point 3.25, there's 3.5, 3.4 is right about there. So I would put another point right about there. Okay, 1.7 more seconds, that's 5.1. So there's 5, 5.25, 5.1's right about there. So that'd be there. Then if I go one more, that's 1.7 added to 5.1, that'd be 6.8 seconds. Well, that's 6.75, so that's about 6.8. So that's right about there. Okay, so that is your data points when you're at one side, go back to that side. So now over here, this side to get to 30 degrees is smack dab in the middle of those two. So you go 1.7 divided by 2, it should be at this 30 degree mark at 0.85. Well, this is 0.75. 0.85 is right about there. So I'm going to put my first dot there. So that dot should be right in the middle of those two. Now, here's 0.85. I'm going to get back to this point after a period of 1.7. So 0.85 plus 1.7 is what? 2.55? So there's 2.5. 2.55 is right about there. So boom, right about there. Then we had another 1.7. That would be 4.25. Well, that's an easy one. That's right there. So boom. Then we add another 1.7. That would be 4.25 plus 1.7. 5.95. That's just a shade short of 6. So I'm right there. So if I look at this, that's 1, 2, 3 cycles. Good. It said plot several cycles, so we're good to go. Now it's time to play connect the dots, but you got to do it in a certain way. If we're, old school, just playing connect the dots, we would just go jagged back and forth, and they would look like V's. We don't want V's. We want more like U's. So they got to be smooth curves. It goes faster, 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 slows down. Faster, 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 slows down. So think of U's more than V's. And I tell you what, the sound effects, it really helps. If it was a V, it'd be just junk, 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 junk. But here, if you're doing more U's, it would be now you get the picture. Uh-oh. I'm so busy doing my dots, I forgot about the cinematography. So there it is, my graph of simple harmonic motion. Not the best thing I've ever seen, but for one-handed, I'm going to take it. Oh, title, always y-axis versus x-axis. So this would be amplitude versus time. Then you got a couple questions and you're almost done. Hope that helped. Talk to me if you got questions.